Hello, everyone. We are happy to welcome you to a new online Pentabar, this time in English, in order to cover US and Europe as well, not only Mexico and Latin America. For the ones that don't know me, I am Andrea Tatarush. I am Project Director and Practice Manager for Pentalog Americas. I arrived here in Guadalajara, in Mexico, about 2 years ago from our delivery center in Bucharest, where I used to be a product owner. Now I'm going to be your host for this Pentabar. If you are wondering what the Pentabar actually is, let me quickly explain it. It's a sort of meetup event where we talk about different topics such as software, newest technologies, agile, QA, and many other interesting items from the IT world. These events are already a habit within the Pentalog community throughout all the delivery centers that we have in the world, and we are happy to continue them in Guadalajara as well. The word bar comes from the fact that we used to accompany these events with pizza, snacks, and beer. Now that we have moved to the online event, we aren't able to keep the bar part, but we have the opportunity of reaching more and more people, more than before, and to meet even more frequently. The last topics that we managed to cover in the Pentabars revolved around Golang, Kubernetes, mindset, React, and today we are going to cover an even more interesting and complex topic, and that's the topic of AI, artificial intelligence, touching upon the influence it can have over the activities of web designers. It's a very, very interesting topic, and our speaker for today is going to be Jensen Baronville, our front-end engineer for Pentalog Mexico. He joined Pentalog about a year ago, and he's a great contributor to our technical community here and to our delivery center. And he's also a TEDx speaker, so you'll see that throughout his presentation. He was, in fact, the very first one to open the series of Pentabar events in Guadalajara. He talked about animations in React Spring. You will most likely find in the comments a link to one of the articles related to that topic. And before actually starting with Jensen, I just want to remind you that you can leave comments anytime in any of the platforms that you are using, and Jensen can answer throughout the discussion. So now, without further ado, I present to you Jensen Baronville.
Hi, hello everyone. Andrea, thank you for that introduction. I'm really happy to be here today, and I want to talk about some cool things about artificial intelligence and running.
Perfect. So we are very happy to have you as a speaker. And from my side, in terms of questions, I think it would be very good if you could answer the question of what does AI actually mean and how it can influence the web design part. And I'm sure you are going to cover a lot of other items, but from my side, that would be the most important.
Okay, well, basically, I want to make a really brief description of AI because it's a really huge field. Basically, it's a field of study where we try to teach the computers to interpret patterns. So basically, it's giving the ability to learn to the computers. That's AI in a basic concept.
Great. Thank you for the explanation. And now what do you have prepared for us in terms of agenda?
All right. Yeah, I have prepared for you. I will show you the agenda of this talk. I will bring you a topic that is really interesting. It's basically using AI models on the browser. AI is used currently for data science, analyzing the weather, analyzing stock prices, analyzing a lot of things, image processing. But we haven't used AI in the whole potential we have. And if you try to use UI for example, making a web app, it's really complex and takes a lot of time. So I will bring you the tools to use AI in your browser and basically do AI in a really easy way. So in the agenda, we will have how to install AI in the browser, the benefits of using AI in the browser. I will introduce a library called ML5, which is an amazing library to do AI, or more specifically, machine learning, which is a really the branch of the AI field that we're going to be discussing. We will discuss about neural networks. We will do a little bit of supervised learning that I will explain in the future. We will see a little bit of models and feature extraction, which are topics of machine learning. And we will focus this presentation on demos, all right? So we will share interactive demos, and we will build apps, and basically that's gonna be the presentation for today.
Great, that sounds very, very good. Because when people generally think about machine learning, they think about, let's say, data science and a lot of data. But now that you've talked about how it can, what can be used for web design, it seems to be a bit more mainstream than we might think. Is that correct?
Yeah. So let me start.
Perfect.
Your questions. Well, what are the benefits of using machine learning in the browser? First, in the regular way of doing machine learning is that you need to build a data center. You need the backend with huge machines, with huge processes running, and a lot of people taking care of the backend thing. And you can really interact with the data. Everything is like fixed. And if you have the chance to use machine learning in the browser, you can do things more interactively. You can make more prototypes. You can make more experiments. And the best thing of using machine learning models in the browser is that you can use pre-trained models in order to solve different problems. What is a model? A model basically is a pre-trained model or pre-trained instance of machine learning. So it's basically a neural network or some algorithm that is already trained with data. So let me share with you the presentation completely. So what kind of models we have currently? We have different kind of models that are already trained, like ModelNet, that is a model that helps us to interpret the image and know what is in the image. We have PoseNet, which is a model that helps us to detect the body parts, let's say, and its movement, like, for example, Kinect. You can build a Kinect prototype using PoseNet. You can have a model for face detection. And the good thing of the models is that people already train those models using regular machine learning. And you can use it in the browser without training the models again or building from scratch your neural network. So that's the benefits of the models. And that's why using it in the browser is a really great thing, because we can change the experiences we deliver to our users, adding those kind of models into our applications. For example, we can use the voice model that will help us to control our websites via voice, or we can use face detection to make, like, for example, in this presentation, we could have a face detection model to know the mood of everybody in this talk. So we can share with you a link, maybe, and you open the link, and then it will record your face without sending data to the server. Just record your face and locally, and tell us if you are happy with the presentation, and trying to imitate the behavior of a real life presentation. So we can do that kind of things without retraining any kind of model, just using the current models that are out there in the open source community. Something else that we can do with the models in the browser and machine learning is that we can basically install or set up our environment to develop apps with machine learning really quickly. Just grab a link from the internet and add it to the HTML, and that's the only thing you need to do. Of course, you need to know about the API of the libraries you're using, but it's a pretty straightforward thing to do. And the best thing that I like of using machine learning in the browser is that you can protect the data of your users. So you don't have to grab the data of the users in your servers that it's insecure, or maybe, the things are happening now with the data thing. We can basically don't use at all the user data. We only install a machine learning model in the browser, in the page locally of the user, and then we can learn from the user locally, send the learnings to our server, and the data of the user is safe in his machine without the need of any kind of data storage or database. So that's the cool thing of using machine learning in the browser. In this talk, we want to talk about ML5. ML5 is a library that helps us to create web apps with machine learning really easy. And I like to think and compare this ML5 with Arduino. If you don't know, Arduino is basically an electronic device that helps you build prototypes with electronics like robots and IoT things, create prototypes really quick. So without knowing a lot of electronics or computer science, you can build a robot using Arduino. So ML5 is something really similar to that. Basically, we can create our own machine learning models in a really simple interface. But before moving forward with this topic, I want to just mention that ML5 is built on top of TensorFlow. TensorFlow is it's basically the open source library of Google to help us to operate matrices. Basically, machine learning and behind everything is a matrix. That's the only thing we have, matrices. Why we have matrices? Because basically a neural network is that, a matrix. So let me explain a bit what is a matrix and why we're using these neural networks. Basically, you have here, let's say, a neural network is a thing where you introduce an input and you got an output. And what's happened in between those 2 points are some operations. For example, I add here a number 1, 2, 3, 4, 5, and the expected output right here is going to be maybe, I don't know, 200. And here, 1.1. That's the output that I will receive. So that's what I'm expecting. So I put my input, and here I'm going to have some operation, addings, multiplications, a lot of things and operations. And basically those operations are described mathematically using these matrices. So behind everything, TensorFlow is what is powering ML5. But we don't need to know TensorFlow, or we don't need to know anything about machine learning to start using our models. So let's dig in a little bit on the ML5 website. This is the ML5 website. It is basically a library to create friendly machine learning. And it's really easy to install. You just need to set up your HTML, get the CDN package that is right here. And there you go. You can use your ML5 models already. Let's see a little bit of the API. You can create neural networks with this library. It's pretty simple. The process to create neural networks. Feature extractions is the topic that we will see in the future. But the interesting part of this is all the models that you can use directly from ML5. For example, we can use image classifier, which you only have to put a function, pass an image. You call the function with an image as an argument, and then you will get the result. And the result will be, for example, right here. I put this image, and the result was that is this American robin, this bird that is right here. But if I put a cat, basically the model would tell me this is a cat. Let's see other models. PostNet, is the one that I talk about. It's basically a model that detects your body and gives you all the data points of your body. So if you want to create a Kinect or you want to control something with your body, you can use this model without building from scratch another neural network to detect those things. So you just need to call again the model. There's this function, one line of code, and then you got all the data points of your body, and you can use that maybe to fit another neural network, maybe to, I don't know, to create an interface to control your computer. So there are many possibilities to do with ML5, and it's really easy to do, as you see. It's just only copy this line of code and then using the data that the models are already giving you. So a body pixel helps you to mask. Like if you want to do a zoom background, you can do it like this, simulate the same behavior, and it's pretty simple. So
I wasn't aware that there are so many options of using machine learning in web design in general, and not even that this kind of library facilitates, makes things so easy.
Yeah, a lot easier. So there are some models, you can interact with them. Just go to ml5.org and you can see what kind of models we have. There are thousands of models out there in the internet to use. And if we want to create our own models, we will need to train it using regular machine learning things like Python or Keras, which are other libraries to do the hard things with machine learning. We shouldn't be doing or creating models from the browser because that's not like the main goal of the browser. The browser is to create interfaces and be interactive, not create models. That's not how you should do it. So it's a very different field. So here in the browser, we're only gonna use the models. And sometimes we can train it, yes, but we shouldn't do it. So I will talk about a subfield of machine learning. I don't want to explain everything, and I will show you the demos only about this field, that is supervised learning. We may cover the other topics in other Pentalog, but in the supervised learning, we have two subfields, which are the classification and regression. What is classification? Classification basically is when you add some data, you have data set, and you add that data, you plug that data in a graph, and you draw a line or a plot to classify things. So one side of the image or of the graph is going to be for cats. The other side of the image is going to be for, let's say, dogs. Every time I add a new dog, that dog is going to be classified below here. And every time I add a new cat, it's going to be classified in this part. And I only have to draw this line to know where is every piece of data that I'm putting. Regression is a little bit different. With regression, we have a linear regression, which is plotting this line, and I have all the values, the numeric values of this. For example, I put the weather of yesterday, and I say it was 90% or 90 degrees, 15 degrees, and yesterday, tomorrow. I can have all that data of the time and the weather, and I could predict using this linear regression. I just have to move over this line to know that tomorrow or maybe the next month, the weather or the temperature is going to be like 40 degrees, something like that. That's a regression. But let's see a regression in one example that I have for you, which is going to be this demo. You're gonna have access to all the demos I will share with you, and the GitHub repo where you can study and take a look at the code. But this demo is basically a color palette generator. So I choose this because we can experiment with numbers and have a regression, and the numbers are basically in the RGB color. So let's say we want to create a tool that is really similar to this, where you can create the palettes for the themes of your apps. So instead of how you will do it from scratch, this tool, is that you need to know the rules of your palette. You need a designer, and the designer will tell you, hey, well, let's combine blue with purple, let's combine blue with yellow, and it's gonna build the rules for that. We don't want that. We want to build a color picker or a color palette generator based only on a couple of rules that I will get from here. So basically what I did in this model was copy the properties of this red, this blue, this lime, this blue-gray color, fit a neural network with those values, and now I can have more colors changing the RGB values. So the regression is changing those values for me. Let me show you how can I do that. First, I'm gonna make a trick that is adding the data. But when I click here, I'm adding these values. The red color, you see here the different combinations and possibilities that I can have with the yellow color. If I select the blue, my possibilities change right here. So basically, I'm training my model with this data that is right here. Okay, so I'm training when I hit add data, and then when I hit train, it's gonna train my model or my neural network with the data that I added. So basically, the process to train starts here, and I have a graph where I can see the loss function. The loss function is basically the function that it's telling me how accurate is my model. You see here, my model is pretty accurate, but there may be some problems with this because I add just a few data. It's useless data, but it's enough data to make this demo. All right. So my loss function is not too bad. Let's see now. Let's create a new color palette using these two colors. Let's predict it, and there you go. Of course, it's generating this color. It's not random because if I hit again predict, it's not changing the color. It's the same color. It's what it learned with the data that I trained. I trained with just few, as I tell you. There's very few data. There's this, but I should have more in the training data set. All right.
Oh, it looks very good.
Let's try with another color that is trained. Should be blue, maybe red, yellow, or green. That should work. Let's change this color to, and let's change this color to RGB. Let's try with that one. Let's predict, and there you go. So instead of going with a designer, doing your research to combine the colors and doing all of those things, you can train your model with another existing palette in the market, and well, you can do things like this. How I did this, I will share with you a little bit of the code. It's not too hard to do using ML5. So basically, I'm using Vue 3, and I'm using the composition API. But we don't want to talk about Vue this time. We want to talk about only the model. So basically, I installed ML5 here in my HTML in the public folder. So here is my ML5 model in the CDN. Now let's go to the current model and regression. Okay. So here you go. First, the first thing that I'm doing is adding creating the neural network. To create the neural net, I just need to add these options, telling to the neural net API that this is going to be a regression. Debug through. That means that it will show me the graph of the loss function when I'm training the network. The amount of inputs. Remember, inputs are these things where the information that I'm feeding into the neural network, and what are my outputs. That basically are my outputs are the information that I want to receive. So I'm putting 3x2 because I have 3 RGB colors and 2 inputs. So let me show you what I mean with that. So there you go. I got 3 RGB color, red, green, and blue. And I have 2 inputs. With the outputs, it's a little bit different. I have how many outputs? 1, 2, 3, 4, 5, 6 outputs, and I have the 3 colors. So that's why the inputs are 6, 3x2, and the outputs are 3 by
6.
Yeah, that one. So basically, I'm declaring my neural net. So this is my neural net, and I'm ready to use it. I'm ready to add data and train it. So how can I do that? Here I have my add data function, and I only need to, what I'm doing here is that to be able to train using the colors, the RGB colors, I'm making a flat array with the inputs and outputs. So that's a pretty straightforward thing. For example, right here, I should have, instead of having this, I will have to, let me share with you a comment. I will have this value, 1, 2, 3, for this color, which is the primary color class. I have this value. And for this other, I have 33, 4, and 100. Those are the values that I have here. What I'm doing is that I'm putting together all the numbers to feed my neural network. Then I have, if you see here, I have my 6 values that I need to feed the neural network. So let's, I'm putting my input array, my output array, and I have here the function of the API to call the add data, to add the data to my neural network. So basically, I'm putting my inputs, my outputs that are the right values that I know. That means that my input is the primary color and the output is the colors that I already know to add, and that's how I'm adding the data into my neural net. And let's see. Well, I lost my code. It's right here. So that's what I'm doing, but this code is a little bit dirty because I'm doing a trick to add more data into the neural net, because as I have few data, a really small data set, I want to have really round and bad results. So I'm basically adding just a few numbers in the RGB colors and adding those numbers as a part of the training or the data set. Basically, I'm doing this with data below that I show you. I'm adding, for example, here I add a 5. And that's the only thing that I'm doing. I'm moving this range a little bit more up. So just to have more data, that's the only thing that I'm doing. And that's the meaning of this code that is right here. That is basically adding the same to the neural net. And once I have my data into my neural net, it's the time to train it. So to train this data, I just need to call brain train. Add the training options, which are this is an array or a JSON with some values. Epochs is the number of times that I will repeat a training with a data set. So I will repeat my training 5 times. But if you have a data, I mean, a loss function that is really big, it's not like it's inaccurate. You can add more. You can add 50. You can do 500. So you can experiment with that, and you can see how your training function change when you change the epochs. And you can add more params, but we don't want to do that in this time. So basically, we train our network, and we are ready to predict. So once you train your model, you can predict it with the values that you have right here. This is the one that I'm receiving in this argument, and that's it. That's the only thing that you have to do. That's pretty easy thing. 4 functions we use in this.
Great.
You experiment with the front end to change how data is shown to the user. And that's the only thing.
It sounds very good. There was actually one person that says that you are very good with the details that you are presenting.
Thanks.
And we also have one question from one of the participants. And he asks, if I train the model with low quality color palettes, my model will generate bad looking palettes as well?
Yeah. Your model is going to be like your data is. So if you have bad quality data, you will have bad quality results.
Okay, so the importance of the data that you are using in order to train the neural network, it's extremely important. How difficult is it to find the right data? Well, in this case with the colors, maybe not that difficult, but maybe in other situations, is it difficult to find the data to train it?
Yes, that's why we have data scientists.
Perfect.
So we already see regression. And let's dig into classification. It's a little bit different and easier because you only have, like, you can add cats, pets, dogs, and you can feed your nets with that. We can use a neural network to do that. And if I change the code that I already have right here, I only need to change the tasks into classification. So I add classification here. And then I can use my neural net to do classification. The only thing with this is that I have to change my data set. Instead of having numbers into my data set, I will put something like, let's say my outputs are this. Let's change the number of outputs to 2. I want to keep the same number of inputs, and I will add the output to be, I don't know, maybe a cat. Maybe a dog, or maybe something like that. I say 2 inputs, right? Let's say output, one output. So I will train my data to be a cat. So every time I try to predict something using the same technique, I will, instead of having the number that I had with the colors, I will have a label, which in this time is going to be a cat or a dog or something like that. We can use this neural net. Or we can use a different kind of algorithms, like the key nearest neighbor. That is a really simple algorithm to do classification. Basically, this algorithm allows you to put your, create some data set segments with your data, where we're gonna have like a training set that we will say that training set is a dog. The red ones are a dog. So every time I add a dog, a picture of a dog, I will say that it's a dog. Then this algorithm will create a circle, let's say, around the dogs, all the dogs that I put into this algorithm. Then I will feed it with cats, and then we will feed it with maybe, let's say, these are fishes. So I train my key nearest neighbor algorithm. Now, when I put a new data and I try to predict something else, I will have a new data point. Where that data point should go? To the nearest neighbor. So if I have a picture of a lion, then the nearest neighbor, following the patterns and the structure of the image, it will say like it's close to the cat, not to the fish. It's going to be close to the cat, and then this algorithm will tell you that basically the lion is a cat, because that's the data that it has in its core. So we have different examples for this. I will show you a demo that is right here. It's the image classifier. I'm using the image classifier using just the model from ML5, which is right here. I'm using this image classifier that is trained with, it's called MobileNet, and it's trained with a lot of research images, animals, that are machines, ships, a lot of things. So let's try to run this.
And what are you going to classify? What type of?
I want to classify the name of the animal. That's the only thing that I'm going to do.
Okay.
So the neural net is already trained. I'm using an existing model to do that. So let's wait that the model loads. The problem with the models in the browser is that basically you have to load the model, and the models are really heavy. So maybe the first time is really, really time consuming for the user. There are some issues with this. Let me see if I can load. Okay, let's try with this image. So let's see what it is. And I just hit predict. And let's see the result of this. Basically saying that it's an acoustic guitar, not even closer. So that's happening because it's not that animal is not in the data set, and the image is kind of weird. So I understand why it's saying that. Let's try with a different image. Let's try with the image on ML5, which is Robin. Let's open the image, copy the link of the image, and let's see. Oh, we can load this image. All right, let's try with a Chihuahua, which is our next example. We have Chihuahuas here.
I was expecting them.
Then I will add the Chihuahuas. There you go. You can see it. There are Chihuahuas. I will predict, and I will see the result in my console. Basically, it says that it's a Chihuahua. It works. Yeah, it works pretty well. So you can experiment, and you can add many images as you want to see if the neural net works. And we are classifying by labels, and the labels are names in this case, the name of the animal. So how I build this classifier? It's a very simple thing. I just load this model, the one that is really heavy. Image classifier. When it's loaded, I call this callback, and then I predict. It's the only things that I'm doing. I'm not doing anything else. So it's a really simple task. The problem with this is that the model is already trained. And if I want to make a classifier, for example, to classify, I don't know, my glasses and my cup, I don't gonna be able to do it because maybe that training data is not in the neural network or in my model. So we need to build a new image classifier. Let's talk about image classification, which is another topic. If you have to train your own image classifier, first you have to do a lot of configuration. You have to do something called convolutions neural networks. It's basically applying different filters into an image, multiply their pixels, segmentate the pixels of the image, and do a bunch of things to be able to introduce those pixels into a neural net and then apply the right label to that data set. So that's a really complex thing. We don't want to do that thing today. We're going to do something called feature extraction. That means basically we're going to take some features in an existing model to make our new to create a new model. So that's something really cool because instead of creating our own convolutions and image classifier, we can use the same technology behind the neural net, the image classifier that we use for this, and then apply new data into that algorithm. So to do that, I create this project, which is the Chihuahua or Muffin project. So I'm gonna feed my neural network with muffins and Chihuahuas, and I will try to predict if the data is a muffin or Chihuahua. That's the only thing that I'm gonna do. I'm gonna use to build that the image classifier, the existing one with MobileNet, and I will use key nearest neighbor. So I will say I will create two data sets, which are muffin and Chihuahua. That's the only data sets I'm creating with this. As you see here. As you see right here, I have the Chihuahuas and the muffins, and I will train it.
They are so similar, so similar.
So it's training. It's taking some time to train. There you go. It's training. And let's try to let's see. Let's add this image. Let's see the result. And it's right here. Let's predict this image. It's a chihuahua. Let's add another picture. Let's go for a muffin. Look, this looks like a chihuahua too.
Yes.
So let's copy this link. Let's go to our classifier. Let's predict. And it's a muffin. It says that it's a muffin. So it's working. It's working because I trained it with this data set that is right here. I'm not using all the pictures to train it. I'm using just a couple of pictures. And for example, if I use this image, I will get a chihuahua too. So but basically, this data set is pretty accurate. So that's why my neural net is pretty accurate. And the only thing that I need to do is using MobileNet, the image classifier that I showed you before, and the key nearest neighbor algorithm. Let me show you the code of that feature extraction.
I do have a question regarding the images. For instance, if the background of a particular image with a chihuahua or with a blueberry affects the identification of the classification of the photo.
It depends. If you have one image, there is no problem. But if you have a huge data set, maybe noise, and it's not going to be accurate, your algorithm or your predictions.
Okay.
So it's you have to experiment at the end of the day to see what's going on.
Okay, thank you.
And well, let's see how I'm doing this. I'm doing feature extraction. That means that I'm going to use MobileNet, the image classifier that I used before. Currently on ML5, you only can use MobileNet. There is not, you can use any other model for feature extraction. Not all the models that are out there in the open source community, on the private community, are, have the capabilities of being to have feature extraction. Just few models have feature extraction capabilities. So we load our classifier, KNN classifier like this, ML5 classifier, KNN classifier, ML5 feature extraction. We load it, and then we add the data. Okay. The first thing we do is pass as an argument the image to predict. This is an HTML image. Then we will call model.infer. Model is our feature extractor. Infer, that means that we want to make an inference of that image. What MobileNet is doing is that before doing the classification, it's doing its convolutions to have like a footprint of the image. It's like the soul of the image. It's just an array of data. That's what this thing is doing. So I'm getting this array of data of the image using MobileNet, and then I'm training my KNN algorithm with that data. So in this case, is the image soul, which are the numbers that I create with this infer from MobileNet, and then I add the label. I add the image in pixels and the label. And the only thing I have to do is pass another image, do the inference again, and then classify using KNN. So these are the steps to create our neural nets. It's really simple, really, really simple. So with that, we cover mostly all topics for today from the supervised learning field. We can make another presentation in the future where we can talk about reinforcement learning, where we can teach a neural net to play a game by itself. So we can do more experiments as you want. Just
okay.
To close this presentation,
I have one question coming from one of the participants. It is marked as an optional type of question, but how does the error function evolve with the number of Chihuahua muffin pictures used during training? How do you estimate the size of the data sets to get a certain error function level?
You don't know. Basically, you don't know. You have to experiment. You have to test it.
Okay.
Of course, we're not doing data science, machine learning. We're not doing things at that level. We're doing things that are really in a really small scale. But basically, you don't know. You need to experiment.
Okay. Could we do this type of experiment anytime in the future Pentabar?
Yes.
Perfect. Great. I really like this topic, so I'm looking forward to anything related to it.
Basically, this could be an example of the use in web development. This is a model from Microsoft, but there are other models out there where you add a picture of wireframe, and then it loads that wireframe. You load that wireframe using machine learning and gives you the HTML portion of that. So let's use this one as an example. Use this sample, and basically it's predicting this interface in HTML. So it's predicting that this is a button, this is a label, this is an image, this is a paragraph, and it's creating that in HTML. So in the future, we will be able to create these kind of things and these products that are really cool. We can use the same algorithm that we use for the Chihuahua or Muffin Challenge to do the same thing.
Okay.
Just train a lot of UI components into our neural net, and then we can draw and add a lot of images of those interfaces, and then we will have the same result. So we can do things like that.
Great. It sounds very, very useful, and it's very good to discover these types of activities that can be applied into web design. Is there anything else you'd like to add to your presentation?
No, that's the only thing. You can follow me in my social networks, Twitter or LinkedIn, and also in GitHub, where I have all the code of this presentation.
Perfect.
So take a look.
Perfect. And what would be the conclusion for today? Because in the title of today's presentation, we mentioned AI for web designers, friend or foe. So definitely, what would be the conclusion? Is it a friend or it's foe?
I don't know the people in the audience, but I think it's a friend. Of course, it's a friend.
Okay. Yeah, we'll see what other items people will mention in the comments. We are eager to see what's your opinion on everything that we are doing. You will also find a comment especially on our Facebook Live, to subscribe to a platform to get access to all our Pentabar videos. And definitely we'll have many other topics to be discussed. The very next one would be related to data-driven applications with React and GraphQL. So we'll have other items to be discussed. Just follow us, be here when we have the presentation. Feel free to ask questions. So we are looking forward to hearing your comments, your opinions, your suggestions. Thank you very much for your time, Jensen. It was very interesting for me, and I'm sure that for the participants it was even more interesting, especially if there are more technical people in the audience. So looking forward to talking to you next, and maybe even a more, let's say, detailed type of project.
Thank you, Andrea.
Thank you, everyone, and have a great afternoon. Bye-bye.
Bye. Be safe.